Hey mathematicians, we've already talked about how to add fractions, but today we're going to look at adding specifically mixed numbers and see if anything changes in our process. So when I say a mixed number, I mean a value that has two parts. It has a whole number and it has a fraction smushed together. So this isn't just 2 or just 1/4, it's 2 and a fourth. Okay, so that's the definition of a mixed number. And we're going to see what we can do to add these two mixed numbers together today. So step one, when you're working in fractions, always, are they speaking the same language? So I can see right here that I have fourths, and here I have eighths. That is a red flag. So if you'll remember from our other strategy videos or in class, we need to make these have a common denominator. So the best way to find a common denominator is just to start listing the multiples of these numbers, essentially skip counting by these numbers, to see if they have anything in common. Whoops. Alright, so there's my skip counting by 4s. Here's my skip counting by 8s. And I'm actually going to stop here because I see they already have an 8 in common. So that's going to be my new common denominator. I'm going to go ahead and write it down here. Alright, so I want my new denominator to be in eighths before I add these two numbers together. Alright, lucky for me, this fraction right here is already in eighths. So that makes it nice and easy. This still is 4 and 7/8. But I do need to change this fraction here. So the question you need to ask yourself is, how do I get from a 4 to an 8? The answer to that is I multiply by 2. If I multiply the denominator by 2, I also have to multiply the numerator by 2. So 2 times 1 is 2. So now, instead of solving the problem 2 and 1/4 plus 4 and 7/8, now I'm solving the problem 2 and 2/8 plus 4 and 7/8. So now these fractions are speaking the same language. I can go ahead and add them. Now whether you start with the whole numbers or the fractions is kind of a matter of preference. I like to start with the fractions. That's just how I like to do it. So that's how I'm going to show you today. So 2/8 plus 7/8. Oops, let's go ahead and try that again. 2/8 plus 7/8. Now I remember with adding fractions that the denominator stays the same and I just add straight across the top. So 2 plus 7 is 9. And my denominator stays the same, so 9/8. Now I'm not done, right, because I've only added the fractions. I haven't touched my whole numbers yet. So let's add our whole numbers. 2 plus 4 is 6. Now here's the question I have for you, mathematicians. Am I done with this problem? Now if you've looked closely at that fraction, there should be something sticking out to you. Do you see that 9 is bigger than 8? That means there's at least 8/8 in here, and then a little bit extra. So that means there's a whole hiding somewhere in here. So we have to regroup. We have to take the wholes out of this fraction and move them over here to our whole number. Okay? So I know that 8/8 would equal a whole. Okay? So I'm going to take this 8/8 away from the fraction and add it back to my whole number. So what is 6 plus 1? Well, that is 7. Now when I take the 8/8 away, 9/8 minus 8/8 is just 1/8. So ultimately, did our process change? Not really. We just had to stop and consider a few more factors. Did I remember to add my whole number? Did I check my fraction to see that it's written in simplest form? Have I made sure that my fraction is not an improper fraction? So even though the process is exactly the same with adding mixed numbers, you do have a few more steps that you want to consider. Can you do this with a picture method? Absolutely. If you like fraction strips, number lines, anything like that, I could have drawn 2 wholes and 1/4 and added that to 4 7/8 and counted up my answer. So any strategy you like that works for just fractions will also work for mixed numbers. I just need you to think about that final answer. Is it written in simplest form? If you've done that, you are good to go.